I've got -3 cosecant of 2x minus 2 pi, or excuse me, pi over 2. And what I want to do is do the whole ABC method of graphing. So I'm going to go ahead and do the 2x minus pi over 2, set it equal to 0. Set it equal to 2 pi. Okay. Get my endpoints. Excuse me. So I have 2x, so pi over 2. Then I got a pi over 4. Adding pi over 2 to 2 pi would be 5 pi over 2, which gives me a 5 pi over 4. Okay. Those are my endpoints of the shift. Now I just graph it with those points in between. Okay. Get this out of the way. What's halfway between 1 and 5? What's halfway between 1 and 3? And halfway between 3 and 5. Since I had a common denominator, I just dealt with the numerators and just did midpoints real quick. Okay. This was a value here was -3. It's a cosecant problem, which means it's the inverse of what? Sine. So sine values start at the value of 0, goes to a, back to 0, opposite a, back to 0. So knowing this, I'm going to have that to worry about. Go to 0, -3, 0, +3, 0. And now I blow it up, if you will. For each one of those 5 points, I'm just going to find the inverse. What's the inverse of 0? 9. What's the inverse of -3? -3. Bless you. Inverse of 0. Inverse of 3. And inverse of 0. Which means because those break points where it was going from 1/2 to the 2, which in this case would have been -6, if you were finding that, you would have been at, we would have started with the pi over 6 and added pi over 4 to get here, 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 and here. And that's what would have given us those upper and lower values. Okay? So if you started by doing that, knowing that it's a sine graph, and you added in your pi over 6 intervals, you know, pi over 6 plus your shift over to the right, you were fine. Okay? But I found out, don't need to do that much work.
What? How?
How? I asked.
Nice.
Good answer.
Jenna, let me ask you this. How many times have I taught pre-calc?
Once.
When?
0.
Well, not. This is your first time.
There you go.
Less.
So,
Less.
each and every day is a new independent event of its own self.
Yeah.
Physics.
Math, yeah. So, I was going through this when I was actually going to ask Fontana about it yesterday, but I didn't get a chance to, about how in-depth they go in pre-calc about these setups. So I just erred on the side of caution and showed you the most difficult way, bless you, the most difficult ways of going about it. So now you should be happy that it's not as bad.
No, it's not.
So you don't have unless I just say, hey, for a bonus point, what are your break points?
There. Red right there.
Safe there.
Let's do the other one then. No, because we're gonna do. It's just two of them. I actually have some problems for us tonight. We'll probably have a little bit of time in class to work on it. We still have to do code table. We haven't done that one yet. Okay. So let's look at the secant. Secant is the inverse of which trig function? Cosine. So we're going to plot the cosine graph with the a, b, and c. So we start with our x plus pi over 4, set it equal to 0, x plus pi over 4 equal to 2 pi. That'll get us our 2 breakpoints. We have negative pi over 4. This what? 5 pi over 4? Yeah. No.
No,
7 pi over 4. Excuse me. Okay. Yes, sir. We're gonna do that today. Okay.
Yeah, negative 5 over 4.
Put your points in. Well, negative pi over 4. 7 pi over 4. Negative 1 plus 7 is 6. Half of that is 3. So we'll be at 3 pi over 4 for the middle. Now it's easy. What's halfway between 3 and 7? What's going to be halfway between negative 1 and 3? Pi over 4. There's 1 pi.
It's not supposed to be 7 times 4.
What, 2 minus 1 4?
Oh, sorry.
That's okay. I've never made a mistake in my life.
I think it's funny when you say that because sometimes you make really
Dumb mistakes?
Yeah.
That's why he says it, Madeline.
I know that. Well, like last year, twice in one day, he told me 2 of like the dumbest mistakes. Like he told me that 5 plus 6 equals 10, and he was like dead serious about it.
Well, what if he had 5 fingers and 6 fingers?
You have 11 fingers.
Oh, are you talking about because the thumbs are
Dude.
fingers? Are you
Stop trying to think.
Madeline,
I was just doing everything I possibly could right there to confuse you.
It worked.
Wait.
Always works.
Our A value is
All
2.
the time.
Cosine starts at your A value, cycles through. And now your inverses. The inverse of 2.
So we don't have to plot things? What? We don't have to do all that extra stuff?
You guys heard.
Yep.
You guys heard.
Well, I heard what you
Kind of.
said, but I wasn't sure, like,
She didn't
I
really
didn't, I thought you meant just at the top of
Okay. Devin nods nervously. Math. Okay. So let's take a look then at cotangent. Okay.
One time last year I tried on the word.
Yeah, I got different ones. Those I figured you can use those as your notes. Those are the worst case scenarios, if you will.
I was like, I'm not gonna let you cry about this man.
I was too young, so we just pretty younger. So I had excuse me.
Look at what you did to my paper yesterday. I was talking about how I didn't want you to cry last year on the math test, so I stopped crying before I handed it to you, and then I handed it to you, and I walked out and cried even more. I didn't want you to see that I was crying. It's funny because I relate to that. It should. What is the word problem test, and I ended up doing better than I did with any other test. But I still cried.
All right. Cotangent's fairly simple to work with. Remember, cotangent is the inverse of tangent.
Wow.
Okay.
Don't eat your sex, John.
Jenna's spicy today.
I won't wish these on.
Let's all stare at her and see how long it takes for her to stop.
You okay?
No.
Not stopping you.
you.
All right. Anyway, tangent is the inverse, or excuse me, cotangent is the inverse of tangent. So if tangent was sine over cosine, that meant that tangent was always y over x. Okay. So I know you guys hate me when I talk about the unit circle, but this all comes back to the unit circle about how the values occur. Okay. Why do you guys hate the unit circle?
It's like a
Oh no, what is that?
That's like an egg.
I'm not gonna lie.
Yeah, just already told it. Good choice.
It's not bad. Better.
That's a pretty good circle because that line's not centered.
Madeline.
It's alright, keep going. No.
It's like Mr. Murphy.
No,
Yeah, you do it.
I almost caught it.
All right, fancy pants.
Almost
No.
only counted horseshoes.
Circle.
Well, I'm not drawing a whole circle.
Then it's not a circle.
That's not a circle.
This circle
You
is
goof.
good. I'm just fixing this line.
You can't pick the marker.
No. Here.
Hurry.
No circle here.
Oh.
I don't have a marker.
You can't pick the marker up either. You have to do it on
Wait, one thing?
Wow.
Oh, gosh.
Oh, see, it's not as good as that.
Oh,
Oh, looks like a Lego head.
Oh, shoot, okay. I know, okay. Oh.
See, it's not as easy as you thought, is it?
No.
Oh, come on.
Oh no.
Okay.
Oh, boo.
That's
Boo.
I think you're missing the bottom left half of the circle.
Ah, even worse.
You John Dilly goof.
Okay, well, now the line's like,
I love my job some days.
no, everyone just likes making fun of me.
No.
I refer back to my previous statement.
There's no bottom left half of the circle.
Thank you.
You're welcome.
Okay, but that line is pretty centered if you ask me.
It's not very straight.
It's pretty
All right, back to this. We have 1, 0, 0, 1, -1, 0, and 0, -1. When you're dealing with sines and cosines, we basically worried about those. The other thing that happened though in tangents that all the time was at the 45s. When it was at 45s, your x and your y coordinates were always the same, just their signs, SIGN, would shift. Remember at the 45s, it was always root 2 over 2? So this was root 2 over 2, root 2 over 2, and then it just became negative, positive. Down here was negative, negative, and then here it was positive, negative. So we knew that tangent was negative here, tangent was positive, tangent was negative, and tangent was positive. So what happens is, if you look at the regular graph for tangent, cotangent is obviously, it just winds up being its inverse, okay? So we go back to just the basic tangent graph to start with. Tangent, excuse me, the generic form of tangent always had asymptotes where? At plus minus pi over 2. And it went through the origin. And it was, it did that, okay? Now, if you think of it in terms of cotangent then, cotangent well, what's the inverse of 0? Undefined.
And then there's gonna be a point, isn't it just like a skinnier like version?
It's just shifted over. It's shifted over, but then it moves the other direction. Okay? It's shifted over because what's the inverse of 1? It's still 1. What's the inverse of an asymptote?
0.
0. Now, if I come back out again, I have another pi over 4 value, and then I have another value here at pi. Are we okay with that?
Yeah.
So if I'm coming out over here again, what would the at, what does this be, at 3 pi over 4?
Yep.
At 3 pi over 4, that's here. Okay? That's what way?
Yeah.
No, I'm sorry, it's one above it. Sorry, you're right. No wonder. Like I said, I never make mistakes. I was seeing if you're paying attention. Teachable moment. At 3 pi over 4, it's at -1. But what's the inverse of -1? -1. So what happens with the cotangent graph is that the asymptotes shift to pi over 2, and it's now a decreasing.
Looks like I see this.
Okay? It's now decreasing. You take your tangent graph, you move it to the right, pi over 2, and then it just decreases its way through. And this is another asymptote here. So your cotangent graph takes your asymptotes right, or left, doesn't matter. We move pi over 2. And instead of it being increasing, it's now decreasing because as it's moving across, it's coming down. That's what cotangents are like. So when you go to plot these things, you still set it up. Remember when we did define the asymptotes with the tangent graph, A, D, and C, we set them equal to negative pi over 2, positive pi over 2? Well, instead of doing it at the pi over 2 intervals, we're going to sum it at 0 and pi. Okay? So our cotangent graph we move them, and instead of being at the pi over 2s to start, we just move them to the right, so you have one at 0 and one at pi. The period between the two is still at pi interval because it still oscillates every pi for the generic reasons. Then you have your phase shift within it. But now, instead of going where your asymptotes would be, is instead of being at negative pi over 2, it's got to be at 0 pi. Does that make sense? We're keeping that same distance apart, we're just moving it to the right.
Is that always the
It's the easiest way to do it. You can go to the left if you want. Set it equal to negative pi over 2 is 0. It's fine. Either one, it works either way. Because your basic interval will it's just the generic way to start the intervals. That's how you get your starting asymptotes and then just move it through. All right. Let me show you an example.
Sometimes you sound like so happy when you say things. Let me show you an example. You sound like so happy like it was like.
I do like this style.
Yeah, I mean, I think teaching would be like a really
Yeah, because
like a lot of other jobs, like I think you could just like keep working and like teaching those.
you can't really fake it.
Yeah, you can't fake like teaching.
And if you get mad at one of your kids, your
I'll just teach you.
like if you get mad at one of your coworkers,
Wow,
sometimes
Trent.
you're not
Easy.
inspired.
That's why.
I know what you're saying.
You have to generally like teaching
Don't know.
I don't think so.
Just some.
Yeah.
Let's try this one. 2 cotangent of 2x minus pi over 2. When you start your cotangent graphs, same basic idea. We're going to we always set the asymptotes first. Because we know what's going to occur between the asymptotes. It's going to cross through the axis. And then we know which direction it's moving, so we just plot the 2 halves and points after that. So we do the 2x minus pi over 2 is 0. 2x minus pi over 2 is pi. Just felt like coughing too, because everybody else was. It's the sympathy. So I get one asymptote at pi over 4. Yeah. So negative 2x is 3 pi over 2. So I get x is at 3 pi. Oops. Draw 3. You okay with those 2 points to start with?
Yes, sir.
All right, we place them in. What value occurs between pi over 4?
Pi over 2.
3 pi over 4,
Pi over 2. Pi.
which is pi over 2. Exactly.
Yeah. That's what it sounded like. Someone went down.
They got the piper down. Probably that was fun. Is it? Anyway. Halfway between 1/4 and 1/2. 3/8. So we got 3 pi over 8. And the other one would be at 5 pi over 8. Our A value was way long time ago at 2. So at 3 pi over 8, what will be the value? Remember, cotangent starts at the top.
Oh, right. You're doing cotangent.
Doing cotangent, start at the top and work your way down.
Sydney.
And that's it.
Like in the parking lot. Don't say
Why
that
is
doesn't
2 cotangent
Wait,
of
where's
2x
you
minus
texted
pi
our
over
parking
2?
lot?
Yeah.
You're texting in the parking lot now too?
I wasn't texting. I was
Seriously?
Down.
You're a deaf witch woman.
That's illegal.
She has that 4 cylinder Jeep, so.
Sydney, you're
Oh,
fine.
you got hate She can't even get that thing on the highway.
Tell. I got 2020, woman.
That's just about to throw down.
Alright.
Questions?
Oh, wait, that one's done now?
That's your vote now?
Finito.
That's a cotangent.
Oh, really?
I agree.
I don't know who he is.
He looks like he's in there today. She can beat him.
The only person.
I'm looking at myself from 20 years ago. Let's do some problems here. Let's
not.
He has what?
Wow. It's like puppy.
I got plenty of hairs. Oh, I know.
You're funny, aren't you? How?
One time.
Eat cow.
The security guard, I stopped my car, and there was 3 rows like left, and he let everybody go. And all 3 rows in front of me, I had to sit and wait, and I always remember getting green. Sorry, this person actually
Go around. Here's my business.
No, I should keep it. Oh.
Oh.
I like it.
All right, we'll go through those, and then maybe tomorrow we'll start working on some of the modeling with the word problem ones. Those, oh no, no, seriously, the word problem ones they give you in these past 2 sections for 4.5 and 4.6, it's a matter of putting the values in the calculator. Matter of putting them in the calculator and going through one single period to find like a maximum or a minimum. It winds up being really pretty simple to work through. So give those 6 a shot. I'll meander about and see how you do. Okay.
Marilyn, try drawing the circle.